Hi everyone, I am Alex. My name's Alex. I am a software engineer on the developer experience team at Trayport. We build trading solutions for the energy market, and for our core trading platform, we have a little bit of a problem for our local development setup. We have a monolithic local deployment. We have over 100 different services and configurations of those services we're deploying as sort of Windows services or IaaS apps. It's slow, it's brittle, there's a lot of duplication in the deployment. It's a real pain when we get new devs on board to get them started. We have this, what we call the JD challenge, when people just come in. The idea is, can you get your local development set up and essentially get as far as making a trade on it? It's very problematic. Not everyone ends up being able to manage to complete it, or they spend a lot of time troubleshooting dependencies that they would actually never touch in their entire career again at the company. Some of our more modern applications are built as, most of them are built as containers, and for many of them, we've been using Docker Compose for their local development setup. That works reasonably well. It's definitely a massive improvement on the older monolithic deployment, but we have the same things being copy and pasted all over the place, the same problems being solved again and again, slightly differently as well, just to make troubleshooting even more fun. There was also a bit of a problem when we want to start trying to communicate between the new and the old worlds. That sort of originally led to some of the more modern applications have to maintain a deployment in both the new and the old worlds. But then when you've got that instance in the old world, trying to inject the local development environment into that setup can be rather complicated because you've got to stop it, you've got to reuse the exact same port, everything else is being bound to, etc. So we're thinking there has to be a better way to do all of this. And our goal was, could we get something, or we could simply clone a repo and just .NET run, Rust up, npm dev, or whatever the language idiomatic thing for a repo is. So then about a year and a half, we came across Aspire. What we really liked was the patterns Aspire implemented that sort of encapsulated and abstracted away a lot of the complexities. If you want a Redis, it is simply an add Redis call, and you get a working Redis instance. There are a bunch of additional configuration you can do for some more complex scenarios, but again, those things are still mostly abstracted away for you. I don't care how the data volume is implemented. I just want persistence, so give me that data volume for persistence. So based on that, we thought, that pattern looks awesome. Could we do the same thing ourselves for our components? And the answer was yes. So I want to take you through a basic example of our accounts component. So accounts is what we use for our login and authentication stack. It does token issuance, OpenID Connect, all of that good stuff. It's a web application. It is containerized. It was in the Docker Compose setup previously, but it's one of the core dependencies almost everything relies on. And for some of those cases, particularly the service-to-service cases, potentially we could mock it out, but they're still, particularly for the user interaction flows, things often need to be able to have an option at the very least of running the accounts component. So to start with our integration, we start by defining a class to define the resource. This isn't strictly necessary, but it will become useful when we want to create the extension method specifically on this resource. So in this case, accounts resource is a container resource. We're now going to create our add method. So the add method is an extension method on distributed application builder. We create our resource, we add it to the model, and then we configure it. So we configure the Docker image, the container registry, the tag, and we also configure a bunch of environment variables. So for this example, we're simply configuring the environment to be development. You can imagine there could be a richer involvement of that. Now we have that, we can start building sort of our helper enrichment extension methods. So for this example, let's say we have a way we can create a set of fake users via a JSON file. We can take that file as an argument to our with mock users method, bind mount that into the container to a well-known path, and then tell the accounts application to read the fake users from that path. So right now, at this point, we have got a very basic integration. We simply create our builder from Aspire. That's just a standard way you create your application builder. And then we call add accounts with mock users. Let's sort of take that a little bit further. So, as in the previous session, with like our open telemetry, when you add something as a project in Aspire, Aspire will automatically add the open telemetry environment variables for you. In a container, you have to tell it to do that. So that's what we'll do. We also, as I said, accounts as a web application. So that means we need to expose a port in order to make it be useful. So we can tell Aspire that we have a port 8080 in the container, and we want the container to listen on that port, the target port, and we'll tell the application what port to listen on by passing it as the ASP.NET Core HTTP ports environment variable. With that, when you then run this thing through Aspire, Aspire will allocate a port on the host, a dynamic port to avoid port conflicts, in this case 57814, and that will map to port 8080 in the container. We can take this a little bit further. We know that our accounts component has a health check endpoint on health. We can configure a HTTP health check. So this means Aspire will keep probing this path. If the health check returns success, it will mark the resource as healthy, as in the first example in the screenshot. Otherwise, it will mark the resource as unhealthy. Where this becomes useful is it becomes useful in waiting scenarios, but it also is really helpful in testing scenarios. So we can create a distributed application builder from the Aspire hosting testing library from NuGet, configure the logging, we add our accounts resource to the graph, and then we build our application, start it, and wait to make sure our accounts resource goes healthy with a timeout on the test, so that if it fails to start or anything, our test will eventually fail. The reason we have this test is this integration. We are putting this integration as a project alongside the component itself. So in our CI pipeline, we publish the application and the Aspire integration concurrently. The way we do this, we have some golden templates that we use company-wide across a lot of the company. The way we do that, we essentially just call .NET pack on the solution, and that will pack our NuGet packages, and we then push them. Convention we use just to make sure we don't push too many things is we turn off packing in the directory build props, and then in the individual packages that we want to package. So in this case, simply the Aspire hosting component, we turn is packable on. We also, in our build scripts, use artifact path layout. It just makes our process a little easier because everything is pushed and published under a single artifacts pack or artifacts published directory, which is just easier to automate the publishing from and packing from in our pipeline. Similarly, for the publishing side, we use the .NET SDK container publishing capabilities. Take a look at Chet Husk's demo yesterday on that for more details. But we simply call .NET publish with the publish container target, configure the registry and tag, and just like with his packable, we use that same approach where we turn his publishable off in the directory build props and then opt in the individual things we want to publish. So that's one integration we've built. We want to build a set of these, and at some point we want to make them work with each other and have to deal with dependencies. So how do we deal with dependencies in Aspire? By convention, we have two ways in which we can do this. Pardon me. We can either have include a dependency on the add method on the distributed application builder, or we can define a with whatever extension method on the resource itself. The convention we tend to follow is if the dependency is something that's sort of mandatory and required, we put it on the add method. That way you can't forget it. And users are going to fall into the pit of success and not end up with creating a component which doesn't work because they forgot to call or they didn't know to call the magic with database argument with method. So an example of that might be a database your app requires on starter. Say you've got an optional dependency. So for accounts, say the SMTP server for sending your forgot password emails. You don't need that most of the time. So that is a great example of something that can be an optional with SMTP server. Or again, you could have, say, maybe you have a view count database or something that your app just gracefully, if view counts aren't there, it just silent. You can just configure it to not log those view counts or something like that. In those cases, we'd use an extension method. So how do we reference endpoints on other resources? So endpoints are what Aspire used to expose ports and things like that. You can get an endpoint from a dependency via the get endpoint method. So in this case, we'll get the HTTP endpoint. We can then pass that through as either an environment variable or with arguments. If you want to do something a little bit more involved and just not get the URL but get constituent parts, you can get that via the property method. One gotcha to be aware of here, there is a property on the endpoint for host, port, and all these various variables, but you don't want to use them here. The reason for that is at this point in your builder, when you're calling these methods, you haven't actually built and started the application. So these ports, hosts haven't all been calculated and evaluated. So we need to pass what Aspire calls a reference expression, which is what those property things are. These reference expressions are a reference to the host and the port, which will then be evaluated later on. Another complexity of the host is, depending on whether you're talking container to container, host to host, host to container, etc., those same endpoints can resolve differently. Local host, host Docker internal, container name. And that's another reason to pass those references. You can as well, if you want to combine those things, you can combine different constituent parts in a interpolated string-like format. However, do be slightly careful. There's a little gotcha there in that you want to make sure the following two examples here, you would think via substitution they're the same thing. Actually, they're not. The reason for that is in the middle example, that URL will be evaluated as a string at builder time rather than at runtime. If you need to do that kind of advanced combination in a separate fit property like that, you'll need to explicitly use reference expression create on the interpolated string, or you can use reference expression builder if you want a string builder like API. So if we have connection strings, so we've got a database rather than endpoints, we can use a lot of the resource types will expose properties for those various values. So this example here is a Postgres database. We pass the server host, port, username, password as parameters from the server, database name from the database. And depending on the resource type, there may be some more useful combination properties like the connection string expression, which will format all of these into a .NET style connection string, or the JDBC connection string, which will give you a JDBC connection string. The other thing we want to do with dependencies is waiting. So there are two ways we can wait. We can either wait for a resource to go healthy, or we can wait for it to go completion. So an example of waiting for healthy would be you've got an app, you will need to wait for the database to be there before you can start it. So you want to make sure the database is healthy, because otherwise your app will try to connect to the database on startup and fail catastrophically if it isn't there. Other times you may have another process to wait for. So migrations, job type things, seeding activities. If you've got to seed some sample data into your app before your app for something your app has to read on startup, again, you may want to wait for completion for those migrations to be done. A little bit of a pit you can fall into here. Just be careful of putting weights in too many places, because each weight can suddenly start to add up. If your app depends on something else, which in turn depends on B, which in turn depends on C, you can end up with quite a long wait before your app starts. Whereas maybe you can move all of those weights, and maybe you can just have your end system under test app essentially just start all the other things concurrently and then wait for them all in one go. If you're working with containers, though, there's a great way to work around these kinds of problems, which is you can use persistent container lifetime. Persistent container is one that will start up, and then if you restart your app host, the container will continue to live and will get picked up again. So you don't have to pay the startup cost again and again and again. This is particularly useful for slow starting containers. SQL Server, Cosmos DB are really good examples where this can be really valuable. Another thing, if you have some older applications where if you can pass configuration via environments and environment variables and command line arguments, things are really easy with Aspire. If though you need to pass them via other means, say you've got config files or heaven forbid the registry, you're going to have to do some additional configuration. So a good place to do this kind of thing is to hook into the on before resource started event. This basically gives you a callback in which you can write some code, and that will run and to completion before the resource starts. So in this case, one gotcha though, you have to be slightly careful if you want anything where Aspire would give you a sort of reference expression for endpoint connection strings. You'll need to make sure you're doing the appropriate weighting just to make sure you're not going to try and use that value before it's available. So here we're waiting for the endpoint to be available before putting the URL in the file we're writing, similar for the connection string. In a more real-world example, you're probably going to do this with XML or JSON rather than a raw string formatted string like this. This is just easier for the demonstration. Another very powerful pattern you can use is sort of the creation of sub-resources. So on all of the resource builders, there is an application builder property, which will give you the original iDistributed application builder. So you can essentially use this to create additional resources to add to the model. So in this case, this is an example of database migrations. If you want a better example of database migrations, go and look at Damien and David's talk yesterday. It's got a much richer and goes into this in more detail. But for the purposes of this talk, the important thing is we can just we're using .NET EF tools to run a database migration. We have the accounts resource. We create a whole separate executable resource to do our migrations. We reconfigure the accounts resource to wait for those migrations to complete. So the .NET EF tool waits for the database to be ready before running, and then the accounts waits for the migrations to be completed. We also configure a parent relationship so that the migrations show underneath the database. One problem you have here, if you're using sort of the builder pattern of Aspire to create these resources, is now you've got two resources. What do you return? Do you return the inner resource you've created, or do you return the original resource you are working on? Generally, you want to return the original resource you are working on so you can continue the chain. Otherwise, you're going to break the chain. You can only from that point onwards run extension methods on the inner resource type. But then the problem there is you can't actually provide any way to configure that inner resource if you want to. If that's a scenario you have, the typical way you can do that is take a configure delegate. And that's a callback that can be run to allow others to configure that inner resource. We also found as we're doing this, there are a whole bunch of common patterns and problems people were solving again and again. So we actually were able to use the eventing framework in Aspire to wire these up in a way that we can solve these in a common way and just let all of our developers just reuse all of those extensions, and also provides a way to add new capabilities as new things come up. And again, this simply works by us building an extension method on distributed application builder. So we call it our with Trayport defaults method. So our callers import the library into the map host, call with Trayport defaults, and we do a bunch of things to just try and make things work with our internal infrastructure. So the two examples I'm going to show here are registry mirrors and certificates. For container registries, we have a little bit of a common gotcha insofar as on developer workstations, the files are a lot more permissive. So you can often pull containers from the Microsoft Container Registry or Docker Hub or things like that. Then they go to our build servers, which have got a far more restrictive firewall, and everything that works locally just fails and blows up spectacularly. So for that scenario, we have an internal mirror which we use to store these registry images. So what we can do, we can hook into, we'll just solve this problem just so developers most of the time just don't even know we've solved it for them. We can hook into the before start event in Aspire, which gives us back the resource model. We can iterate over that. And for every resource with a container image annotation, we can fix that annotation so it points to our mirror registry. So if it points to Docker.io, we correct it to point to our mirror registry, and then we prefix cache Docker.io to the path it pulls that from. Our actual examples are a little bit more complex. We have a few more registries we handle. We have a bit of logging, etc. but this does the job for the slides on the demo. We also internally, we have a number of internal certificate authorities which we use for internal websites, and trusting those within a container is a little bit of a pain. So we want to make sure all those certificate authorities are trusted within our containers. Prior to Aspire 13, this was a whole bunch of horrible stuff. You can find a blog post by Anthony Simmons on this, whereas now in Aspire 13, there's a really nice method to simply say, trust or take all the trusted certificates from the host and trust those on the container. The one gotcha here is in the event, we get a collection of resources, not a collection of resource builders, and the extension methods tend to be on the resource builders. However, there's a method to create resource builder that allows you to take a resource and convert it to a resource builder, which then allows us to call that extension method. We also have a convention where if we have a prod image, it goes to one registry, a non-prod image and a test image, it goes to another, and we differentiate based on whether the tag has a Semver pre-release component. We just create a nice little helper method to encode that behavior. So how did it work? How are we doing? We're now up internally to about 33 different integrations internally, and that number is rising. And we can use that to build a lot of really powerful applications now. So this example is one of my colleagues put together a couple of weeks ago for the automated trading platform. Each of these circles is a component that's essentially a NuGet package. He was able to just pull these in, compose them all together, and we have a working solution. That's really awesome. It's not all sunshine and rainbows, though. We have a few challenges. Keeping containers up to date is a bit of a pain. We've got 3 options, all of which have pros and cons. Refer to the latest tag is the sort of simple, obvious thing. Works most of the time. The one gotcha is when you run the latest image, if you already have an image tag latest locally, Docker will use that and not put a new version. That means potentially in a horrible worst case, someone could end up with a 1-year-old version of the dependency. All the devs on your team are probably going to end up with a different version of that, which could cause some fun differences between developer machines. Although you can work around that by just running Docker pull regularly. You can combine that with image pull policy always. That will guarantee Docker pulls the latest container. However, if for any reason your network is unavailable, Docker will just completely throw its hand up in the air and refuse to start the container. The other option, because we publish a lot of these integrations alongside the application, we get a new version of the integration every time we release a new version of the application. So we can use something for a stable tag. So, for example, we can get the assembly version and use that as our image tag. This does guarantee we get stable dependency versions between developers who've checked out the same code, but it also has a similar drawback in that developers will not pull image updates unless they pull the NuGet updates to the NuGet package, although things like Dependabot can help with that. None of these are perfect. They've all got their pros and cons. We also have a whole bunch of non-containerizable executables. The beauty of containers in Aspire is containers handle not just running the container, but also acquiring the container, whereas with executables, we have to handle that acquisition. Start off with cheated, and our monolithic deployment deployed a bunch of executables to well-known paths, so we could cheat to start off with and just use that path. We're exploring, and I've got some proof of concept just not quite ready to show yet, of using dotnet tool to share these around, and also using there's some new capability in dotnet 10 that can help out with this. So dotnet tool exec allows you to install a tool and run it in one go. It's also got some native tooling capabilities for AOT apps, and we think we might be able to smuggle non-dotnet tools into dotnet packages like that. Projects, we also have a little bit of a challenge in that we build our integrations as containers, but locally for debugging, projects are much better. We can do some horrible stuff. This is almost this will be an entire 20, 30-minute session by itself, so I'm not going to go into too much detail, but we can essentially take the resource out of the model, put a new one in its place with the same name, a little bit of fix-ups in order to run the container as a project without having to maintain 2 completely duplicate branches of code. How we want to go forward in the future, more integrations, the way we set our integrations up, is that we've got a massive improvement on the 100 dependencies we potentially had previously. We've still got perhaps more dependencies than we'd like to have. Can we mock some of those up? Can we make some of those more optional? Things like that. Can we use things like the deployment capabilities of Aspire to build ephemeral environments? So you've got a PR, someone wants to do some exploratory testing on it. Can we just have a simple deploy this and you get a Kubernetes environment within a couple of minutes? Are there other things we can do with testing? Chaos testing would be very interesting if we've got all this model. What happens if we take our database down? Does our app fall back to a reduced capabilities mode as we'd expect? Thank you very much. Hope that was useful. If you have any questions, let us know in the chat or join the Aspire Discord. I'll be around there to answer questions. And if you have any feedback, there's a QR code on screen.